Assalamualaikum, and today we'll be going on to the next protection on cable protection. Cable protection. Where's the pointer? So typical protection scheme, normally we will have the most basic is overcurrent and fault only, pilot wire only, or both pilot wire and overcurrent fault, or pilot wire and directional overcurrent and fault for parallel system. So the pilot wire scheme normally is using a circulating current scheme and also the balanced voltage scheme. So this is the circulating current scheme. So it's measuring the current on one side. This is, for example, substation 1, this is substation 2. This is the feeder to going out. This is the feeder incomer of the substation 1. So under normal condition, for any external fault, for example, if there's any fault here, or there's any fault here, for example, there's a fault here, so both CTs will be reading the same current magnitude and angle, but the current flowing by Kirchhoff law within this secondary circuit would sum up to 0 . Where else, if there's any fault within the boundary of the CT, so this CT will not be reading any current, but this CT will be reading the fault current. So there will be a fault current circulating, which is enough to trigger the operating coil of the relay of the differential relay for the line. So this is a balanced voltage scheme. It's similar, but it is based on voltage . So under normal condition, when there's a fault on the outside of the zone, so there will be a current circulating here as well as a current circulating here, and the build up voltage across here and the voltage across here is the same. Since both voltage on each side is the same, there can be no current flowing through this circuit . But if there's any fault within this within the protection zone, the voltage build up here is 0 , because there's no current flowing here. So the voltage across this coil here is across this resistor is 0, but there's a voltage across this resistor . So the voltage is enough to operate the operating coil . Okay. Alright. So pilot wire, we have summation transformer, so it requires only one pilot channel, meaning we do not have to send one pilot wire for each cable. So we just have to send one pair of wire to measure all for comparison of all these three phases . So it converts two phase currents into single signal for comparison . So transformer usually is within the relay . So this is a summation transformer. So this will be coming in from the CT input, red, yellow, blue, and return . And this is the output, secondary. So on the other side, there will be a similar summation transformer. So under normal condition, when there's an outside zone, there's no current circulating within this. But when there's one internal fault, so there will be circulating current here, and that will trigger the operating coil of the transformer of the line differential . Okay, I will not dwell too much on the setting for this kind of Solco relay . So pilot wire faults. Pilot wire is highly dependent on good pilot wire. So this pilot wire is basically the wire that we lay side by side to the main primary cable . So the pilot wire may be defective due to open circuit. So bias current may not longer circulate. So relay becomes unstable during high loads or external faults. And this will operate during internal fault . So if your pilot wire is open circuit, you must be careful . For external fault, it may trigger the operating of the differential relay. While for short circuit results in high bias current, relay will not operate during internal fault . Okay, if the pilot wire is shorted, and reverse connection after maintenance. So this could be some of the problem that happen lah when you do maintenance secondary injection or primary injection. You might have reversed the secondary connection. So when you switch on, there's no load, there's no issue. But once the load comes in and reaches the minimum pickup current, then it will trigger lah nuisancely. And when you find out, it's actually due to some reverse connection that you did after the last maintenance. So pilot wire fault, if it's open circuit for circulating current, internal fault, it will operate. For external fault, it may operate or may not operate. While for short circuit, it will never operate. And for external fault, it will be stable lah. For wrong connection, it may operate for internal fault and also be unstable lah, may operate or not operate for external fault. For balanced voltage relay, if it's open circuit, it will not operate for both internal and external fault. While for short circuit, it will operate when there's some current flowing through the circuit, and it will be unstable lah for the external fault. Same goes for the wrong connection. So this is an example of the pilot wire relays. Circulating current type, we have the SOLCO R or the so-called RF, the full wave version. So in the so-called RF or SOLCO RR, there's a padding resistor lah. So this padding resistor is to compensate the pilot wire resistance. So this is just a very brief calculation of how to set the padding resistor. And we also have the much older model GEC Translate S. These are the typical example pilot wire relays. These are all using the twisted pair cable. But now all the modern pilot wire are using fiber optics. And we also have the balanced voltage, the GEC Translate HO4. Maximum of 1000 ohm pilot resistance. So it cannot be used for long distance cable. So if you were to use for long distance cable, you'll be going for the circulating current type lah. But if you're using fiber optic, there's no issue lah for that manner. So if you think this material is good, please share this material to your electrical friends, and do subscribe to my YouTube channel, Crux of EE, and then my Facebook page. Please like my Facebook page, facebook.com/Crux of EE. And if you have any other questions, please throw them in the comments below, or you can email me directly lah at cruxofee@gmail.com. Thank you.